Hello everyone. Today we will talk about SWOT of IP security. First, what is SWOT? SWOT or strengths, weaknesses, opportunities, and threats is a framework used to evaluate a company's competitive position and to develop strategic planning. This is designed to facilitate a realistic, fact-based, data-driven look at the strengths and weaknesses of an organization, initiatives, or within its industry. S stands for strengths. It describes what an organization excels at and what separates it from the competition. W stands for weaknesses. It stops an organization from performing at its optimum level. O stands for opportunities. This refers to favorable external factors that could give an organization a competitive advantage. T stands for threats. Threats refers to factors that have the potential to harm an organization. Now let's talk about IP security. IPsec or Internet Protocol Security is a suite of protocols and algorithms for securing data transmitted over the Internet or any public network. The Internet Engineering Task Force or IETF developed the IPsec security protocols in the mid-1990s to provide security at the IP layer through authentication and encryption of IP network packets. What is IP security used for? IP security is used for protective sensitive data such as financial transactions, medical records, and corporate communications as it's transmitted across the network. It also used to produce or to secure virtual private networks or VPNs where IP security tunneling encrypts all the data sent between two endpoints. Strengths. First, network security. Due to the fact that IPsec operates at the network level, it is completely invisible in its operations. Moreover, the users are not required to interact with them, making them recommended for VPNs. In addition to that, because the IP security works at the network layer, all the traffic that passes through the network are monitored. That is the reason why IPsec-based VPNs are recommended to clients who need to protect inbound as well as outbound traffics. Second, application independency. Since the IPsec VPNs are operated at the network level, there is no application dependency here. Whatever the application type used, IPsec does not depend on it. All the applications in IPsec are routed with IP, making them compatible. The only thing that is required is the modification in the operating system. Next is data privacy. The privacy of that data is safeguarded in IPsec using public keys. Any data that is being exchanged between hosts and the network uses public keys to ensure safety. Additionally, by ensuring safety of the keys, the users can make sure the data comes from the right host, not from any spoof sites. Therefore, whatever the content present inside the data packet is safeguarded from eavesdropping and other forms of spying. Next is network support. Due to the presence of IP layer, IPsec can be implemented to any network from all the sizes. Irrespective of any network from LAN to WAN, they can be applied including the internet. Fifth is authentication. IPsec does not authentication by means of placing digital signatures on each data packets. Any type of interference from a third party is protected here. Thus, contents inside the packet header cannot be modified without detection. And also it does identify verification for two ends of a connection. Weaknesses. All the data, or first is CPU overhead. All the data that is passing through the machine needs to be encrypted and decrypted constantly. Hence, IPsec requires high processing power for the CPU. This is especially disadvantageous if the size of the data packet is small. As IPsec generates large overheads, the performance of the network will be diminished. Next is compatibility. Some software developers do not stick to the procedures of IPsec. As a result, it can create compatibility issues with several softwares. Moreover, IPsec does not have any consistent standard for its own compatibility. Third is algorithms. Securing algorithms in IPsec are prone to crackings. If anyone happens to use those algorithms, their security is at greater level of risk. However, latest algorithm models today are known to prevent these vulnerabilities. Next is access range. Since IPsec provides wide access range, it has higher chances of giving privileges to other devices in the network. For example, if any of the PCs happens to encounter malwares, all other computers in the corporate network are affected. Therefore, unless there are special security measurements, IP security-based network is always vulnerable to cyber attacks. Last is firewall restrictions. Sometimes, due to the restrictions imposed in the corporate firewall, user will not be able to access the internet. Even if his own company's network, therefore only by contacting the network administrator, the user can access the respective network. Opportunity. First is reduced key negotiation overhead and simplified maintenance by supporting the IKE protocol. IKE provides automatic key negotiation and automatic IPsec security association or SA setup and maintenance. Second is good compatibility. You can apply IPsec to all IP-based application systems and services without modifying them. Third is encryption on a per packet rather than per flow basis. Per packet encryptions allows for flexibility and greatly enhance IP security. Threats. Cut and pass attack. This attack will only be possible on two networks that use IPsec as a tunnel between the two routers that link the networks. There is also a requirement that the attacker has access to a second machine in each of the two networks. Second is session hijacking. Similar to the previous attack, by looking at the diagram, Blackbeard could have created packets that are intended to arrive at Ben, as if they were sent from John. Instead of stealing John's packet and asking router B to decrypt it for Drake, Morgan now pastes Blackbeard data into John's packet and it is decrypted by RB and sent to Ben as though it came from John. And that's it. Thank you and keep safe.